It's our pleasure to have Dr. Mohammad Khair with us. He will present a talk about automated translation of Islamic literature using large language models, Al-Shamela library application. So you are welcome, Doctor. You can start.
Thank you very much. Let me just share my screen. Bismillah ar-Rahman ar-Rahim. Salatu salam ala Sayyidina Muhammad. Thank you all for being here. I will today discuss the automated translation of Islamic literature using large language models, and particularly with the concerning the Al-Shamela library application. I am co-authoring this paper with Dr. Majdi Sawalha, and I'm the CEO of the QuranComputing.org organization, which is a nonprofit organization here in the US. The translation of classical Islamic literature using large language models is very important effort. Today we have Islam is a religion of 1.8 billion or more around the world, and the majority of the Islamic scholarly writings were authored in Arabic. But yet only 20% of that population speak the Arabic language as their native language. So with very limited translations available into other languages. We developed the automated translation of the classical Islamic literature works contained in a Shamila library into English by applying large language models, essentially through API communication to the large language models to translate or automate the translation of of Arabic into English of the works in this Shamila library. We accelerated the translation by using multiple parallel threads of computing so that we can, because many of these works are very large volumes or multiple volumes of books. The LLMs really offered us an opportunity to do all this work at low cost. And enabled high-quality translation on diverse corpus of Islamic scholarly works, like the Quran exegesis, and the Hadith and jurisprudence, books on jurisprudence. All in all, so far, more than 250,000 pages have been translated into English from over 100 large volume books. We do plan to continue this effort all the way up to 2 million pages, inshallah. These are just some of the titles of these books. I'm not going to go through them, but just wanted to give a sense of the type of books that we've translated. All these translations will be available on our website at QuranComputing.org, hopefully within a month time frame. The importance of automated translation is that, Arabic is the representative language for the Islamic sciences. We have the importance of this work is to foster cross-cultural exchange and education and learning. The LLMs enable us to cross these language barriers with multiple languages translation being potential for example, the OpenAI GPT-4o Mini, which was the model of choice for our translation work, able to cross into 29 languages. And the Google Gemini 2.0 Flash is more than 100 languages. So far, we've used the OpenAI's model, but there may be also an opportunity to include the Google Gemini for future work. The selection criteria for which model we wanted essentially to, obviously the number of and type of languages that are supported by the LLM is important, but also ability to understand Arabic language clearly, and that's as most of these Islamic books were written in Arabic. And then the high quality of translation that's provided, the low cost of the API calls to the GPU or GPU hardware cost, that's was one of the criteria we evaluated. because we're doing so much large volume of translations. And the speed of response, obviously time is of the essence when we are doing these translations of millions of pages or hundreds of thousands of pages. So we need to make sure that there's ability to speed the response, especially through parallelization of codes through multi-threaded execution. These are some of the languages that are covered by the GPT-4o Mini, which was the model of choice for this effort and this paper. We've obviously focused most of the work right now on English, but we do have intentions to cross into other languages downstream. The evaluation of different LLM models, essentially we did look at open source, local large language models, such as Llama and Quinn, Silma, Jace, and Mistral. And then we also evaluated the commercial proprietary LLMs, such as OpenAI's GPT-4o and 4o Mini, and the Anthropic Clouds, 3.5 Sonnet and 3.5 Haiku, and then the Google Gemini 2.0 Flash Express, or experimental, I should say. The commercial models essentially provide a better opportunity for us to do this work because of the reduced API cost, which is you can think of it as a low variable cost per call, and then the ability to do multi-threaded parallel computing at high speed via API calls. Versus if you have a local GPU with an open source model loaded on it, the model may be free, but you're paying for the very high fixed cost of GPU hardware. And then you may only be doing single-threaded, as in other words, you can only do one call, one page at a time through these local GPUs. So it's going to provide you a low execution speed. So these are some of the cost structures for these models and performance, in terms of quality of translation and number of languages. And right now the top line, the 4o Mini, was at $1.5 or 15 cents, in other words, per million token input, and 60 cents per million token output. And I believe the Gemini is even 75% of that cost at the moment. So that will be a future consideration. The challenges that are overcome by LLM attention architectures is to enable cross-language translation is that there are differences in grammatic structure across languages, and that's very important to overcome in kind of the order of grammatic structure in a sentence in different languages. So that's one of the key features that LLMs are able to overcome, or this transformer architecture is able to provide us with. There are differences also in linguistic expressions. So mapping these expressions across lingual across languages is very important. And then there are different dialects, so these LLM models are also used for speech-to-text and text-to-speech, and can translate across dialects, written dialects across languages. So they're highly suitable for translation. Again, they do offer large context length. They vary from 4K to 128K. I think the 4o Mini is 128K tokens, 128,000 tokens. That's roughly 100,000 words in context. And we are translating one page at a time. So the chunking or the kind of segmentation of these books occurs at the one page as a one-page boundary. And it enables, by the way, we do have some overlap across these pages so that there's continuity in sentence structure and sentence translation. And then there is the transformer architecture can also offer multiple attention heads, making it efficient to map the sequence-to-sequence relationship, focusing on key relevant information, making it ideal for translation tasks, as well as these attention heads are able to offer a parallelization across computing architectures of GPUs. So during the training or pre-training process of these large language models, it does build a very knowledge maps, if you will, vector embeddings that are essentially approximated to each other so that across languages. So if you ask a question in English and you ask you'd like the answer in Arabic, for example, you can create. There is that cross-lingual similarity, approximations that are done. So those vector embeddings, whether they're in Arabic or in English, they still map to the same words, there's similarity in the vector embeddings between same words of different languages. And then also the LLMs offer customized, it can be easily customized through simple prompting, which makes them ideal for use. So this is some of the instructions or prompting that we've done on these LLMs is to provide proficient translations without transliteration, as some models may fall into that. And use Islamic terminology and scientific expressions to keep the quality of the translations high, keep the translation accessible, understandable to the reader, preserve the truthful representation of the source. When we're doing translation for Quran and Hadith, to provide both the Arabic source as well as its translation. This is a way to preserve quality of the content of the translated text, and to maintain page and paragraph formatting as possible with bold headings and separate the chapters. Yeah. These are so kind of the process of our translation, just a high-level diagram, but essentially the output is available in both Postgres database tables as well as in Word format, Excel format, and Adobe PDF. And for some books, we were even able to generate audio tracks, MP3. And a large volume of these books in Al-Shamela library are in PDF content. Not all of it is digitally available. About 13,000 is digital, and the rest are in PDF content. So in order to access those books for translation, we also used large language models for OCR, performing OCR on PDF content. So particularly speaking, the multimodal large language models are able to accept as input text and images, perform computer vision on the images, and provide you output text. So these multimodal models are key for enabling OCR for Arabic books, particularly in PDF format. But the way to do it is we have been able to save each of these pages of these PDF books into images, improve their high resolution, in other words, scale their resolution, and then process them with filters to remove background noise on the and sharpen the text essentially. And especially important is these diacritic marks on the and punctuation marks on the words that sometimes are maybe neglected or removed by some traditional OCR. And then we take these images, the enhanced images, and we convert them to base 64 strings, and then pass that into the prompt query for computer vision and OCR, kind of extraction of the text. This worked really well. Beside this process that I described here, Landing.ai has a Python library with also that is enabled similarly, and it's focused only on anthropic models. So these are the instructions that we gave for the OCR to instructions or prompting for the multimodal LLMs is to maintain the original text, maintain the diacritic marks, make sure that the Quran verses have their complete markings, and Quran symbols, to maintain the Quran symbols as well, and the pay special attention on the hadith for chain of narration, formatting of hadith and verses. These are some of the examples where we have a page in a book and it's extracted text on the right. Here's another example. So the other thing is with respect to Quran and Hadith, we wanted to make sure that there is a translation accuracy. So while these bodies of text, holy kind of the holy book of the Quran and as well as the Hadith are of critical importance to maintain its translation quality. And we do have large databases of human effort, in translating these Quran verses and the Hadith particularly. And to avoid any sort of translation quality issues, we employed RAG, retrieval augmented generation, to essentially extract the text from a trusted database, provide it to the LLM, and asking it to substitute the Quran translation and the Hadith translation with the trusted version from the database. So RAG enables semantic similarity search to match using a cosine similarity of metric of the embedding vectors to identify the verse that needs translation and to extract the translation and feed it into the output of the translation process. So that's a very important step. Also important is to validate the translation quality, and to do that, we wanted to do the essentially we have a path on the left that is the typical generation of the translation via OpenAI, and we were similarly able to do so that's going from Arabic to English. And then there is also a secondary model that we can employ to go from English to Arabic, back to Arabic. So we essentially have an independent model, the Anthropic model, validating the OpenAI translation quality. And comparing essentially the source Arabic text and the back translated Arabic text. And the means of comparison is, again, by doing vector embedding of both the source and the back translation, and then doing similarity scores on them. So that's a kind of maybe an innovative way of performing validation for automated translation. These are some of the scores, similarity scores between the cosine similarity scores for for this back translation validation. On the left is the when we used the same model, the OpenAI model, for both the forward translation and the back translation. We can look at the cosine similarity between them. And on the right is when we use the independent model, the Anthropic model, as a back translation engine, and comparing that with the forward translation. We can see quite a bit of correlation between the classical Arabic source and the reverse translation Arabic in terms of cosine similarity. In conclusion, essentially that the LLMs offer deep learning architecture offer really strong tool for linguistic understanding, ability to retain longer historical contextual information, and offer that longer contextual information can reduce the fragmentation for translation, through the chunking process. So we don't do translation of one sentence at a time, rather one page at a time. And the availability also of low-cost API offers opportunity for us to really take advantage of these computing engines for large volume translation or translation of large volume text. And then the quality of the translation is, we have a validation technique for it as well. So that helps us in trusting the quality of the translation. We did apply this on random, multiple books randomly selected. And we essentially highly recommend the use of LLMs as reliable translation tools, especially the GPT-4o-mini and the Anthropic Cloud Haiku as well. And in the future, currently we're evaluating the Gemini, and we think that also should be part of the recommendations. And that's all I had. Thank you very much for your attention, and any questions I'll be happy to.
Thank you very much. Thank you very much. Any question? Asking about 0.7. Why 0.7 for similarity?
What is the similarity score for 0.7?
Yeah. So the similarity score, and I'll show you maybe the graph here. Here it is. So 0.7 was selected. Essentially, we look at that to say if it's below 0.7, we then the quality of the translation needs to be improved. This graph at the bottom here can show you that type of scoring. Again, there are two lines. The blue line is using the Anthropic as an independent model for similarity comparison, and the orange is using OpenAI, which is the same model in the forward and back translation phases. And you see similar scores. So 0.7 is essentially, this is page by page, you can see the similarity score there. The 0.7 is the kind of a threshold level that we evaluated the quality of the translation textually in the output, kind of by reading both the source and the back translation to see how close are they in meaning. So anything below 0.7 is kind of these kind of outliers at the bottom are we determined to be of poorer quality translations, or could be improved, in other words. So the majority of the points that we saw were above the 0.7 threshold that we selected. And 0.7 is a pretty good score given empirically when we look at the output, the actual output of the translation process, and how close is the source to the back translated text in terms of its meaning. So we arrive at this threshold empirically. There's no magic around it. Yeah. Any other questions?
Thank you. Any other questions? No? Okay, thank you very much, Engineer Mohammad, for this presentation, for this project. And hopefully this will be continue, you will be continue like developing this translation into other languages, not only English. So this is the first, we know this is the first stage, but you plan for other languages that are used.
That's very true.
Other countries,
Yeah,
yes.
that's very true. We did attempt about 12 languages for one of the books, and we are evaluating the quality of those translations with people from those native to those languages. So hopefully, once we gain confidence in the quality, we will proceed with that as well. Yeah, thank you very much.
Thank you very much. Yeah. Yeah, there's a question. Yeah, he can hear you.
Yeah, I just had one question about the retrieval augmented generation. You said you use it to verify or validate the translation. I wanted to ask, not specifically for the translation from Arabic to English, but in other tasks like question answering, how effective is RAG in verifying the answers? If I ask like some question about Quran or Hadith and to a model, and then it uses some RAG, but because I've seen applications like this that's been used, how effective is it? Have you experimented with things like that? And what do you think about this?
Yeah, it's very important. Actually, I can let me. I want to share with you some work that I've done on that, and let me just share my screen quickly. So hopefully you can see the screen. This is accessible at Quran-search.streamlit.app. Okay. This is a program that did a vector embedding of the entire Quran. Here is the Quran and all its verses. And you can ask in natural language, this is a query from the user. You can ask a question, let's say, which verses talk about Siyam. And it will do vector embedding similarity searches and bring you all the verses that talk about Siyam, fasting, and with their so this is actually it does really well. The quality of the results can be improved by essentially adding to the embedded text, adding a subject or adding a higher level summary, if you will. And that can help in the retrieval accuracy improvement. As you see on the left side here, we have the similarity scores between the query and the actual verses that are presented. And we can maybe zoom in a little bit for you to see the verses that are talking about Siyam and food, etc. Are all listed here and with a similarity score. So you can explore this offline, Quran-search.streamlit.app. We also used, there's another application we developed, Quran Analytics.streamlit.app. And this one is similarly allows you to do This one does the there's a database of all the analytics structure of the Quran, and you can ask a question in natural language again, in Arabic or English. For example, how many words are in Surah number 2, for example, and you ask a question in natural language, and it brings you back, translates the query to SQL, from natural language to SQL, and brings you back the answer from the database. That's another application that is leveraging large language models for, in this case, for translating natural language into an SQL query.
Do you share how these were like made, or like some documentation paper or anything, or how you created these models for the embedding, the vector embedding?
Yeah, certainly we can share some information. If you can leave your email with Dr. Majdi, and I'll be able to get back to you.
I am interested in establishing the link between standard Arabic, modern standard Arabic, and classical Arabic, that is the language of the Quran. I think that studying the Quran from a linguistic perspective can actually be very likely linguistically. Especially if you're interested in historical semantics, to learn how meanings evolved over time. This gives a window to the intellectual development of the speakers of the language, how they developed at intellectual level. This would be exciting for me personally to pursue.
Okay, Dr. Ashraf, anything in mind?
The new direction would be looking toward how large language models serve a set direction when it comes forward. This is becoming very evident, and this is the new direction. I think Mr. Khair some of what they are doing in for translation, and the type of large language models that they are experimenting with. There are two more that can be explored. And I would recommend that this would be for researchers, for students. This would be very good for in terms of opening.
Dr. Bayan, anything in mind? I said it's
For the example, I use chat to ask question answer or any question on the Quran. So, for example, if you ask about something related to Islam, and just for a religious question, try to obtain relative verses that are related to this topic. So maybe, but it wasn't any basic one. We didn't use, we applied the same technique for different languages, so there was no one week specific or Arabic or something like that. Just try to share learning and see how it was worked. So maybe we can do much more than this.
analysis. No.
Maybe I think it was stressed already a couple of times today that going to the original languages is a very valuable part in this research, especially that the corpora that we are talking about are very old. and we have issues of semantic shift as was mentioned. So I think this is at least something that I'm working on in my PhD. So yeah, I think it's an important thing. I'm actually sorry that I didn't know about this workshop. I only realized when I was signing up for calling. I submitted my work for the resource language modeling, which is tomorrow. But yeah, that's what I'm doing. I'm working on the Bible in ancient Greeks in the original language. So I think the comparable that between the corpora are really interesting to also look at them in our service languages.
Okay. Another point is how to keep connected. Like, are you interested to attend or participate in the conference and this workshop and other conferences, or by making it a standalone conference? Because some of these conferences are very expensive. But the best thing they are sitting and all of them just they are better to be covered with these conferences which are well known. And we might compromise like these proposals. So what do you think? Shall we run this workshop again first? What do you prefer? Do you prefer with large conferences like calling and Elbrek and these conferences, or would you like a separate conference? Would you like it in person like this, or would you like it online? So what's your preferences?
I think if you separate from co-lane or Starbase CO, you're going to have an opportunity to drastically lower the fees and make it more attractive to humanists to participate. But staying attached to this conference will get you more NLP. Maybe it's a compromise. You could alternate.
Yes, so like I was thinking, like maybe the next time, if you can go to kind of like another main menu at people who could maybe understand better kind of like these older languages, really just kind of like but may not know kind of like newer learning techniques and tools to use. So that would create like an opportunity to kind of like people who know kind of like these techniques come to the conference, like present the work from the side that we have the tools, but it's kind of like older language. And then those could just kind of like maybe provide the challenges that they face because they wanted to use newer technology, but they didn't have kind of like easy access or knowledge of using these newer technologies. So then the conference is also kind of like a good venue for them to like see both sides of that and then collaborate.
What about social activities or like social networks and good stuff? Would you like to join like email list or social network and something like that? Which is more professional or less annoying?
This would be a good idea.
Yeah, it's like Facebook or Twitter or Instagram or just email list like Google email list.
The Google email list for me.
Yeah. I think Google email list is more professional, so we can like people can ask and people can reply and answer questions. So I will construct and share it with you. Then you can share it with other people. So like we will have more. And we will put that comments from these. Mr. Mohammad Khair, what would you think about this question? I didn't hear your opinion about this workshop.
Yeah, I think it's a great workshop. I really wish I was there in person. So really apologize for my lack of planning or tightness of time around being able to be there in person. But it's a great workshop. Really enjoyed the conference, and I think it's at least a window of opportunity for us to present our work on the use of large language models, and specifically here we're talking about the translations of large volume texts. I think just in the future, if there will be a virtual session, we just need to improve the audio of it, that's all. But otherwise, looks great. Thank you all for your attention and feedback.
Thank you very much for this. Any other comment? Any other suggestion? So at the end, I would like to thank you all for attending this conference, this workshop, and I would like to thank all the presenters today, all the attendants, and we would like also to thank our keynote speaker, Professor Ashraf Nagar from Shahir University. And we would like to thank you.
Thank you.
Very nice. And thank you so much. Thank you very much. And السلام عليكم ورحمة الله.
عليكم السلام.